Howdy, we're Team Real UV, and we're here to talk about our engineering project called SafeGate. SafeGate is a security system here to increase the security, connectivity, and technology in our communities. My name is Sherman Wilder. I'm a firmware and hardware engineer, project manager, and sponsor / advisor.
My name is Kevin Castañeda. I'm the database developer for this project.
And my name is Alfonso Solis, and I'll be the software developer for this project. So in our presentation, we'll be going over our problem statement, essentially what we hope to accomplish with our project, our background as to where we got these ideas on what to do with our project. We also have a conceptual block diagram that will show an overall picture of what we plan to do and how it works. We also have a functional block diagram that will show with more detail on how all these things work together. We also have a visual experiment to give you guys an idea of what our project looks like. We also have some of our future goals and things that we hope to accomplish. And then at the end, we have an overall summary of what we've done.
So right now we concur the problem with security. Security is a big factor in society right now, and also front door security devices and community apps. With our system, we're trying to look at the different ways that we can incorporate security devices and community apps, so that way we can confirm that a person actually is a resident and can get inside of a community app without doing an email verification setup.
So we've taken these pre-existing formats and created a device that increases security, gives the user access to a community phone application, creates a two authentication process that will confirm residency and reduce the amount of notifications received.
So for a conceptual block diagram, visually that you can see right here, that we have the user on the left and the home on the right. We have the security system on the home, and the user also holding their cell phone and the keychain fob that we're using for connectivity. So the home security has an ad hoc network, text motion, and connects to the internet and also our database and server. So depending on the different inputs of the system, motion, confirm residency, anything like that, it can go through the database and store itself in a file, and then or send notifications. That way, eventually, maybe when it's confirmed as residency, depending on how long the person has been at home, can give them access to our community app. So for our functional block diagram, we broke it into three different sections: our database, a security system, and also our gate key.
So for our gate key, at the center of it is the ESP node MCU, which is what we use to communicate in our ad hoc network with the central security system. It is powered by a coin cell battery and uses a power saving mode, so that way when it's no longer in range of the security system, it uses less power and doesn't require the user to have to replace the battery as often.
So for our SafeGate security system, we're connected to a porch light. We use AC voltage and turn that voltage to a DC using the voltage transformer. So mainly our node MCU and our security system is connected to the gate key through an ad hoc network. Also the Wi-Fi network the user is provided, and the server that we want to connect to through a API key.
So the database system uses this API key from the security system to establish a communication with the server. This information gets passed through the domain and sends data to the PHP file. The PHP file then categorizes the data into the database, which the database updates the table into a different PHP file, which then updates data into a web table that we could access from anywhere using a stable internet connection. The database also has the ability to send notification using HTTP requests. And here's a visual experiment of what we accomplished so far.
So here's a hardware aspect of our security system. It's a breadboard design with a node MCU, some LEDs, and a motion sensor. The LED lights up when there's motion detected, and the node MCU connects to the Wi-Fi network.
Here's also the hardware aspect of our gate keychain, which also uses a node MCU device as a center. It gets power from a small cell battery and then transmits and connects with the central security system.
For our database, we're using PHP MyAdmin, which uses MySQL database management system. This lets us establish those PHP files for communication that we were talking about. Right now, what you're seeing is the categories of the tables. Right now, we have match and verify for testing purposes. And we have reading time, which is a timestamp that updates whenever match or verify is received from the system.
On the software aspect of our security system, the security system ways to detect motion. So it detects motion and also detects the presence of the keychain device at all times simultaneously. So it goes through two different directions. So if motion is detected and there's no keychain near, the top right picture, you can see that it says 2.91 is the voltage threshold that the motion detector sends, and it sends a notification to your phone to your phone using the HTTP request data that use the API key to send to the database. At the bottom right, you can see it says, bottom right, you can see it says same one, 2.91 volts, and then the motion detected, and it indicates that the keychain is near, so it doesn't send any notification to your phone.
For our gate keychain software, we essentially have 3 states. When it is not connected, which you can see from the leftmost picture. From the center picture, you can see when we're in the connected / transmitting stage, where essentially we send an arbitrary value just so that way the security system and the database knows that we're detecting a good reading and that is in the location. As you can see, the time also goes up with it. And then for the verification, once it reaches 60 seconds / a minute, we then send to the database that has been verified and also send a 100 as an arbitrary number just to signify that. And then we cause a client timeout so that way we can continue to verify the user that is in the location.
So here's an example of how the database looks like within the server. Right now, what you're seeing is the in range and the match, which establishes the communication via the system when motion is detected within the network. Then after, for our purposes, we use 1 minute for a timer. Like Alfonso mentioned, that confirms the resident. Also, if motion is detected when the device is not around, an intruder alert is displayed to the phone. And also you can see the timestamps that are automatically updated with the other information in the table.
For notifications, we plan to implement a motion alert notification, a confirm resident notification, where once they get that confirmed resident notification, they would be able to use either an app that we designed or in tandem with another company who has a neighborhood communication app where they'll be able to access it after being verified through our system.
For our future goals, we have plans to, like Alfonso said in previous slides, create our own app or implement our design with previous systems already. Really, we want to futurely design a keychain device that's be rechargeable and maybe even have an app that replaces the keychain and so you can connect to other users inside the home. Mainly, and then later we want to sell our system and device in bulk to communities and apartment complexes to actually use them.
So we discussed the problems with existing security systems, communication between these systems, and resident verification. We gave an overview of our background of improving pre-existing formats to resolve these issues, and we have shown visual examples of our project using the conceptual and functional block diagram. We have also walked you through a visual experiment showing the process of our system, and finally, we have shown our future goals we plan to achieve in the future to improve our product for both us as developers and for residents as users.
If you'd like more background on the project itself or more information about our respective roles in the project, feel free to contact us at the phone numbers and emails that we provided here on this slide. Once again, thank you for listening to our presentation. And just remember, Real UV is here to increase the security, connectivity, and technology in our communities. Thank you.